I'm Wan Lee. Today, I'm going to explain about measurable association. Measurable association is the relation between two categorized variables A and B, especially after independence test. Okay, let's see. What is measurable association? In the context of testing independence of categorized data, if two variables x and y are not independent, one measures how related they are. For continuous variables, we have the relationship between two variables. The degrees of association is typically measured by the correlation coefficient. However, for categorized data represented in a contingency table, the following measures of association are used. One, simplest one, phi. Phi is Greek letter. Phi coefficient is known to be suitable for a 2 by 2 simple contingency table. When 2 by 2 means, okay, A and B categorize only two groups, okay, like that. When each of the two variables is categorized into two groups, phi is used as a measurable association. Phi is defined square root of value of chi-square. Chi-square is what? Test statistic in this case, okay? Chi-square, value of chi-square divided by n. So if chi-square, value of chi-square is very big, okay, like this, then what is that? You reject A and B are independent, null hypothesis, because the value of chi-square is too big. So you reject null hypothesis. The test statistic value chi-square divided by sample size n, and then taking the square root, that is phi, is how we calculate phi. It can be understood as an adjustment for chi-square, value of chi-square, increasing with larger n. If you have big, large sample size n, the value of chi-square increases, okay? So just adjustment for chi-square by dividing n. However, since phi does not have an upper limit, no ceiling, it is not perfect measure of association. You understand that? Kramer V. Kramer V extends to the general P by Q contingency tables, although it also has limitations in its use. The same limitation. It is no limit. Okay, no upper limit. Okay, V will be obtained as phi from this value divided by square root minimum of P minus 1 and Q minus 1. So you have contingency table, okay, 5 by 6. Then what is this minimum P minus 1 and Q minus 1? That's going to be 4 and 5. Minimum is 4. So in this case, 5 by 6 contingency table case, phi divided by square root 4, 2. So it is also very simple and not usually used. Contingency table, contingency coefficient C is a very famous one. The contingency coefficient is a measure widely used to assess the degrees of association in contingency tables. This coefficient is values between 0 and 1, making it ideal for interpreting the strengths of association. Okay? because we know correlation coefficient, which has a range -1 to +1, correlation coefficient, right? So this contingency coefficient C is chi-square divided by value of chi-square plus n. It should be less than 1. N is a sample size. So square root also less than 1. So many persons use this contingency coefficient C. Okay, you may see that coefficient from some report or presentation. Now, lambda. Lambda is a little more complicated measure. Lambda is useful when two variables in the contingency table are nominal variables. You know nominal variables? It is a job, right? Region, that kind of thing is nominal variables. Lambda is derived in two ways depending on the causal relationship between A and B. Causal relationship. Let me talk about causal relationship later, a little later. Let's see. M is the error that occurs when predicting the maximum category of A. Let n be the error that occurs when predicting maximum category of A from each category of variable B. Can you understand that? It is pretty hard to understand what M and N. But in this case, in mind, let's talk about the M and N with the example. Lambda going to be defined to be M minus N by M. Okay? For example, simple example, let us denote attitude toward the college donation admission system as variable A. Attitude to donation admission, okay? A. And B, income as variable B, income, B. So we have contingency table like this. The contingency table obtained from a total 1,487 adult as follows, like this. We survey sample size 1,487 and we obtain this kind of a table. In this case, in this example, M represents the error occurred when predicting attitudes inversely, which amount to 5 or 8. Okay, you predict what attitude the person has, agree or disagree, one by one. Okay, then you better predict all of them disagree. Then you make error 5 or 8. That is M. Error occurs when predicting the maximum category of A. You predict all of them disagree. Then you make error 5 or 8. 5 or 8. That is, say, M. Understand that? For N, the error are as follows. For low income, 982, you predict them disagree because this is bigger than 274. Then you make error 274. Okay? For mid income, you predict what? Disagree. All of them disagree. Then you make error 146. And for this high income, all of them agree because 88. Then in this case, how many errors? 49. 49. So 274 plus 146 plus 49 gonna be N, resulting N equal 469. So this value 508 minus 469 Chap.6-9 divided by 508. That's gonna be lambda 0.077. Understand that? Okay, here the causal relationship between A and B indicates that income is the cause, while attitude A is the effect, right? So it's going to be expressed as lambda A cos, sorry, B cos given A effect is 0.077. The value of a lambda indicates no relationship between the variables. Knowing the value of one variable does not provide any information about the value of the other. Lambda 1 indicates perfect relationship. Knowing the value of one variable perfectly predicts the value of the other. Okay? So it is very reasonable measure of association for the contingency table. Lambda is useful in social sciences, market research, and any field where categorical data are analyzed to understand relations and dependencies between categories. Okay? Get it? Okay. Social science and business major, that kind of they use lambda frequently. Okay, this is the end of chapter 6, categorized data analysis. We studied the three tests: goodness of a fit test, independence test, and homogeneity test. Okay, and the next chapter is good one, analysis of variance, ANOVA. I am confident to explain that a little complicated topic easily. Okay, let's see ANOVA in chapter 7. Thank you so much. This is it today. Bye.